name is Simiside Dlamini. We're going to be doing the pre-prepared for tutorial 10, regression and correlation analysis. And we're going to do the first question. The following table gives data on the number of workers and the number of units produced in 7 different factories. So you have the number of workers, and then they give you the values, and then you have the units produced, and then they give you the values. So you need to identify which one is the dependent and which one's the independent variable. So in this case, I don't think practically you can't say that the units that are produced determine the number of workers that they are. So our dependent variable will be the units produced, and then our dependent variable will be our independent will be the number of workers. So our x is the number of workers, which is our independent variable, and then our y is our dependent variable, which is the units produced. So when they say fit a least squares regression model to the data, they mean that they're talking about this equation is equal to beta naught plus beta 1 x naught, and then since we don't have the population, because this is the equation of the population, what we're going to do is we're going to use the closest approximation to this, which is going to be b0 plus b1 x1. And then now what you're going to do is you're going to punch into your calculator the values. I think you go to your stat mode, and then you use the second option, which is the one that says a plus bx, because it allows you to punch into values, the variables, the x variable, which is going to be this, and your y variable, which is going to be that. So you're going to punch in all of that, and then you're going to save your data, and then you're going to now look for this value and this value. Can you please help me out? I'm not sure which. So you go back, sorry, can I borrow that? Okay, so you go shift after you've saved your data, and then you go back to your stat mode, and then you go to option 5, which is regression. When you get there, you have 5 options. The option A will be this, and then option B will be this. So this is your intercept, and then this is your slope. So in this case, what you get is y is equal to negative 75.7143 plus 6.3036x. And then the question goes on to say that interpret the slope parameter. So what they mean by that is for you to explain what this means exactly, what the slope means. And what the slope means that the number of units produced, which is y, and you can specify like units produced, increases by this value, which is the b1, so 6.3036 for each increase in x, which is the number of workers. So you can just write that out like that. And then now we're going to move on to G, where they ask for a prediction interval, 95% prediction interval. So a prediction interval is similar to a confidence interval, but in this case, it differs in one way. So I'm just going to write the equation for a confidence interval and then show you how the prediction interval now looks different. So you have y cap given that x is equal to x naught plus or minus t n minus 2 comma alpha over 2, and then the square root se squared 1 over n plus x naught minus x bar over n minus 1 is x squared. So this is your confidence interval. So when they're asking for a prediction interval, the equation is the same. Now the difference is here, it's going to be 1 plus... it's going to be 1 plus 1 over n. So this is the prediction interval. So that's what they asked for in this question. Now, the way we get these values, we're going to start with this one. So when they ask you for the prediction interval or the confidence interval, when you're talking about regression, they're going to tell you what x naught is in order for you to be able to get what your y cap is. So in this case, they said that there are 60 workers at the factory. So our x naught is equal to 60. So now we need to determine what our y cap is when our x naught is equal to 60. We're going to use this equation that we got over here, and we're going to plug in 60 into where x is. So it's going to be y cap x, given that x is equal to 60, is equal to negative 75.7143 plus 6.3036x. Sorry, our x is now 60. So we're going to multiply this by 60. And then can someone please punch that in and tell me what they get?
Just make your handwriting slightly bigger.
Okay.
Yeah.
So that's 6.3036.
Yes.
302.5017.
302.5017. 5017. Okay, so now we have that value. And then now we're going to move on to this. From other chapters, I'm pretty sure you can remember that. We're going to do it the same way. So our n, they said it's 7 different factories. So now when we're talking about regression analysis, it's always n minus 2. So 7 minus 2 is 5, I think. And then...
Yes, an idea.
So they also said that it's a 95% prediction interval. So it's 1 minus alpha is equal to 0.95. That means our alpha is 0.05, which means alpha over 2 is equal to 0.025, which I'm pretty sure we've seen quite a number of times. So can someone please check for me in the T table, which I think is table 3, what value we get for that? Are we getting 2.571?
Yes.
Okay. Okay, and then now we're moving on to SE. In other cases, you'd have to calculate SE, but in this course, you're always given SE. And in this question, SE was given as 27.1207. And then now we'll move on to this part. So our x naught is what was given in the question, which is the 60. Our x bar you get from your calculator from option 3, where you're going to get x bar, you're going to get y bar, but you need x bar specifically, don't use y bar. And then we also need to calculate our sx squared, and we have a formula for that. Do we? No, we don't, sorry. It's not SB1, sorry. Our Sx squared is the standard deviation of x. So you're going to go to the 3 as well, where you got your x bar, and you're going to go for Sx instead of sy, and then you're going to square whatever you get there, and then you're just going to punch everything into the calculator. So now let's just put together everything that we've got. We start here, which is 302.5017 plus or minus 2.571 squared root 27.1207 open bracket 1 plus 1 over 7 plus 60 minus, does anyone have the x bar for me? Are we getting 40?
Yeah.
Yeah.
Okay, 40 close bracket squared, sorry I forgot a squared here. Squared, and then over n minus 1, which is going to be 6 times sx squared. Are we getting, for ss squared, are we getting 21.6025? And then we're going to square that as well. No? For sx?
21. Yeah, I got that.
Okay. Okay, so now we have everything in our calculator and our equation. We just put it into the calculator. We start with our minus. So our lower bound would be 22.3.4384, depending on how many decimal points you go for. Decimal places, sorry. 81.5651. So that is your prediction interval. And then now we're going to move on to testing the slope parameter. Okay, now we're testing the significance of the slope parameter. Our slope parameter is beta 1, but because we don't know what beta 1 is, we're going to use b1 to test that significance of that slope parameter. What we're going to do is, they said the level of significance is 0.05. So we're going to do normal hypothesis testing, whereby our beta 1 is equal to 0. Sorry. Our null hypothesis states that our beta 1 is equal to 0. And then our alternative hypothesis is going to say beta 1 is not equal to 0. Because they asked us to test the significance, that's the difference between our null and alternative hypothesis. Our null hypothesis states that our beta 1, which is the slope parameter, is not significant, because if it's equal to 0, then it doesn't matter. It doesn't really then the whole equation doesn't have a relationship between x and y, because every time you're going to punch in 0 here, you're going to get a 0 and therefore get a 0 there. So when it's not equal to 1, it means that it is significant and it does have an influence on y. To our test statistic is going to be t is equal to b1 minus beta 1, and then over SB1. And when we're doing regression analysis, it's always distributed with degrees of freedom that are n minus 2. And then 3, now we're dealing with our rejection region. There we said it's not equal to, so we're dealing with the two-sided test. So we're going to have positive and a negative. Sorry? Small, oh sorry. Okay, so we're going to reject, is it fine? If H naught is, we're going to reject H naught if not, sorry. sorry. We're going to reject H naught if T observed is greater than Tn minus 2 of alpha over 2, or
Getting smaller.
T observed is less than negative Tn minus 2 of alpha over 2. So our Tn, our Tn minus 2 is T of 5, 0.025. What are we getting for that? 2.571. Okay, so which means that this is negative 2.501 over here, and then this is positive 2.571. And then 4, now we're going to be calculating our p-value. No, we're calculating our t observed, sorry. T observed is equal to, then we're using this test statistic. Our BI is what we calculated over here, which is the 6.3036. 6.3036. And then our beta 1 at the null hypothesis is 0, so minus 0. We're going to come to the side here, and we're going to calculate our SB1, which is equal to SE over root n minus 1 Sx squared. So our SE was given in a question. It was 27.1207 over root n minus 1 is 6. And then Sx squared is what we get from our calculator from option 3, which is 21.6025. And then we're squaring that because here it says Sx squared. And then what we're supposed to get is 0.5125. So that is what we substitute into here. 0.5125. And then that gives us a T observed of 12.997 or 998, depending on how you round off. And then now we're moving on to our p-value. Our p-value is equal to, since it's a two-sided test, it means we have this over here and we have that over here. So our p-value will be times 2, will be 2 probability of t. Since we have a positive, we're going to focus on this one, because we said we're going to reject if it's this or that. But since what we got here is a positive, we're going to focus on this. So since here we said T observed is greater, we're now going to say that T observed is less than T.
Simi,
Yes.
for your observed value, I think it's supposed to be 12.2997.
Okay, sorry, yeah. 12.2997. Like that?
Yeah.
Okay, thank you for that. So now we're going to move on to looking for our p-value. So the T observed. So now we're going to get 2, just to not confuse yourself, you can divide both sides by 2 to get rid of that, so that you don't make the mistake of calculating the probability here and not multiplying it by 2. So we're going to divide this side by 2 and we're going to divide this side by 2, which gives us the half p-value is equal to the probability that T is less than, our T observed was 12.2997. So now we need to go to our T table and look at the degrees of freedom of 5.
Isn't like less? Isn't it supposed to be greater than?
Yes, sorry. I said T observed is less than, then I wrote the opposite. Yeah, if T observed is less than, then it means that T is greater than T observed. Okay, thank you. So now we need to find the corresponding probability in the T table. I think if you first look at the first table, then you look at the extended table. And if you still can't find it in the degrees of freedom of 5, you can see that at the end, the numbers keep getting smaller and smaller, but you still don't find what you're looking for, which is 12. So what we're going to do is we're going to say that this probability, sorry, can I just write here?
Let's see.
Okay, so what's that number at the end for the degrees of freedom of 5? What's the very last number that we get there on the table?
6.869.
Okay, so greater than
869.
869, not 6. Okay. 6.869. Okay. And that is much less than, it's much greater than T, which is greater than what we have there, which is 12.2997. And that the probability of that is 0.0005. And then since we said this is half of the p-value, what we have over here, we're now going to multiply this by 2, which is going to give us, so this is half of the p-value, and we want the p-value, not half of it, so we're going to multiply both sides by 2, and then when you multiply this by 2, you get the p-value, and then when you multiply this by 2, you get 0.001, if I'm not mistaken.
Sure.
And then in our conclusion, we're going to say that since we use the positive rejection region, we're going to say T observed is greater than Tn minus 2 comma alpha over 2, and our p-value, our alpha was 0.05, so if our p-value is less than 0.001, that means it's much less than that. So our p-value is less than alpha, which means we reject H0. And if we're rejecting H0, and H0 says that our slope is insignificant, if we're rejecting H0, then we're concluding that at a 0.05 level of significance, our slope parameter is in fact significant. And done. A question?
Quick question. Well, it's not a question. I just want to clarify there by your p-value. So what you're saying at the top, yeah. So what you're saying is that the probability of 6.869 is greater than 12.2 what?
Yes.
It's probability, not the number.
Oh, so you're looking at the values at the top on the
Yes.
table.
Yeah.
Okay.
Because the values at the top of the table, what is happening to them, the probabilities are getting
Yeah.
smaller and smaller.
So
So
the
any big number would have had a smaller
Smaller
probability. Yeah.
okay. Thank you.
So it doesn't really matter which side.
As long as you get the right
I
sign.
was right. Okay.
As long as it's like, you could have started with this, then you would have said this
Much
is
less
less
than.
than,
Yeah.
Oh, okay.
yeah.
Yeah.
Okay.
Can I go after her?
Yeah.
Thank you.